Your dog is asleep in the corner of the room. Its legs are moving, small rhythmic kicks against nothing, a quiet sound from the throat, then stillness again. You've seen this. Most people assume they know what it means. The dog is dreaming, probably chasing something, running through some open field in its head. It's one of those explanations that feels obvious until you look directly at it and ask what it's actually based on. What almost no one stops to ask is whether that's actually true. And the answer, when you follow it far enough, stops being simple very quickly. Sleep was not supposed to be this complicated. For most of the 20th century, the dominant scientific model treated it as a maintenance window. The brain goes offline, systems reset, nothing experiential happens. That model held until the 1950s, when researchers identified a stage of sleep unlike anything they had documented before. Rapid eye movement, REM, named for the visual signature it produces. During this stage, the body enters near-complete muscle paralysis, while the brain activates to levels nearly indistinguishable from full waking consciousness. Not a low hum, a spike. The same regions that process memory, sensation, and decision-making during the day fire at waking intensity, while the body lies completely still. The brain during REM is not resting, it is running. The question researchers were then forced to ask was what exactly it was running. In 2001, Matthew Wilson and Kenway Louie at MIT recorded the hippocampal activity of rats as they navigated a maze. The hippocampus is the structure most associated with memory encoding and spatial navigation. Specific neurons fired in specific sequences as each rat moved through each section of the course. Wilson's team mapped those patterns precisely. That night, while the rats slept, they recorded again. The same neurons, the same sequences, the same order, the same timing intervals. The rats were running the maze in their sleep. Wilson described it not as noise or random activation, but as the brain going back through the day's experience, consolidating it, running it again in the dark. This was not maintenance. This was reconstruction. The rat wasn't simply offline, it was somewhere specific. That study opened a question research has been expanding ever since. If rats replay their days, what do other animals replay? And how far down the chain does this go? The answer keeps getting stranger. Zebra finches learn their songs by listening to adult males and then practicing, a process involving weeks of gradual refinement. In 2000, Daniel Margoliash at the University of Chicago found that neurons responsible for song production in zebra finches fired during sleep, in patterns that matched those active during actual singing. The birds were running the song at night, not producing sound, the paralysis of REM prevented that, but executing the full motor sequence internally, going through the motions without any motion at all. A juvenile bird, mid-learning, not yet capable of producing the song correctly while awake, was rehearsing it in sleep, building in the dark towards something it hadn't yet managed to do. Then in 2021, researchers at the Brain Institute at the Federal University of Rio Grande do Norte published footage of sleeping octopuses that shifted the terms of the conversation. During sleep, the octopuses cycled through rapid, dramatic changes in skin color and texture, the pale, flat posture of camouflage, the dark flush of threat display, the rippling, chromatic patterns used in social signaling, the full behavioral vocabulary of an octopus, compressed and cycling across the skin while the animal lay motionless. The octopus shares no meaningful evolutionary history with rats or birds. Their last common ancestor lived more than 500 million years ago. The octopus nervous system developed on an entirely separate track, 2/3 of its neurons distributed through its arms rather than centralized in a brain. Whatever it is doing in sleep is happening in an architecture with no direct equivalent anywhere in vertebrate biology, and yet something functionally similar to what the rat was doing in the maze and what the bird was doing with the song appeared to be happening here. Something that looked, from the outside, like experience being processed. The researcher who led the study, Silvia Medeiros, described watching an octopus cycle through what appeared to be a complete hunting sequence while asleep. The skin went pale, then flushed dark, then rippled. Less than a minute, start to finish. She described it as watching a film with no sound. Here is where the data runs out. and the harder questions begin. What the rat study showed is that the brain replays experience. What the bird studies show is that sleep is used to practice and refine. What the octopus footage suggests is that this process is not limited to any one nervous system architecture, that wherever there is a brain complex enough to produce experience during the day, something goes back through that experience at night. But none of these studies can answer the question underneath the question. What is it like? Neuroscience can map the firing sequences. It can identify that the rat's hippocampus is reconstructing the maze, that the bird's motor cortex is running through the song. What it cannot do is get inside those processes. Whether there is something it is like to be the rat running the maze in the dark, whether the bird is anywhere when those neurons fire, whether the octopus goes somewhere in sleep, or whether the skin just moves through its patterns and there is nothing it is like at all. What the replay theory does allow is a narrower version of the question, not whether animals experience dreams, but what the content of that experience might be, if it exists at all. The rats in Wilson's study were replaying a maze, the day's most demanding cognitive task. Researchers who extended this work found that the brain tends to prioritize experiences that were emotionally intense or required significant learning, which raises a specific possibility for animals whose days are organized entirely around survival. A prey animal's most significant experiences are threats. A predator's are hunts. If the brain returns to what mattered most, then what the cat is running through is not the warmth on a sofa, it is the stalk, the calculation of distance and speed, the sequence the species has refined over millions of years and which the individual spent hours practicing in waking. Dogs spend roughly 12% of their sleep time in REM. Their eyes move beneath closed lids. Their paws move. In studies where researchers temporarily disabled the paralysis mechanism in cats, the animals got up during sleep and acted out sequences of stalking, chasing, and attacking, eyes still closed, the full predatory sequence running without any stimulus, the body performing what the brain was running through without registering the difference. Whether the cat is anywhere inside that sequence is the question the data can aim at but not reach. The dog in the corner with its legs moving was doing something the brain considered worth doing, running its sequences, rehearsing its patterns, going back through whatever the day gave it. The same process the rat ran in the maze, the bird used for the song, the octopus ran through in a body built by 500 million years of entirely different evolutionary history, arriving at the same place in the dark. What that feels like from inside, whether there is an inside to feel from, is the question every study sharpens, but none of them close. The tools are getting better, the data will accumulate, but at some point the measurement ends. And what is left is the animal lying still, somewhere inside whatever sleep is, doing something the brain decided mattered enough to do again. Your dog is running in its sleep right now, chasing something, maybe being chased. You'll never know which one. If your pet has ever done something in their sleep that made you genuinely stop, drop it in the comments. I want to know what they were doing. Like this if it made you look at your pet differently. Subscribe, because the next one is going to mess with your head even more.